Hello, my name is Marc Carter. Thanks for the opportunity to introduce you to the growing effort which has become known as the Electronics Manufacturing Technical Education Project. Many of you share, I'm sure, our concern as we've seen the accumulated expertise and experience of many of our colleagues leave the industry through retirement and closures. This has been simultaneously coupled with the difficulty in finding new young people that are interested in moving into the manufacturing end of electronics, and rather than complain about it, we decided to do something about it. For the past several years, we've been involved with an effort which has become a prototype for what we hope will be replicated at various locations around the country. This prototype effort was centered around Michigan Tech with considerable input from Calumet Electronics and many others. With that, I'd like to transfer over to a video interview that Judy Werner of Altium did during the first year of the operation of this Michigan Tech Calumet exercise. And I think it'll give you a fairly good outline of how this project got started and what we're trying to accomplish there.
Hi everyone, it's Judy. Welcome back to the On Track podcast. Today we're having our first ever On Track field trip. We're on site at Michigan Tech, where today's podcast guest is Dr. Chris Middlebrook, and he teaches a class here on printed circuit fabrication. So we were able to sit down in his lab where they actually make circuit boards here right on campus. So we're going to talk about his students, the program, and all the amazing work here they're doing to prepare EEs for the real world. Chris, thank you again for inviting us here to MTU. It was a delight to meet your students today.
Well, it's great to have you, and really appreciate the support that Altium's been able to provide.
Yeah, it's our pleasure. So can you tell us a little bit about your personal and professional background and tell us a little bit about MTU?
Sure. I've been a professor here since 2007 at Michigan Tech. We've had a research project previously a number of years back that was involved in high-speed interconnects within printed circuit board shops, where we got involved with Calumet Electronics just north of here. And so that kind of set the stage for some of this sort of work here. Michigan Tech is a smaller engineering-focused university, but we do pride ourselves in the hands-on kind of approach, and engineers that are well-versed within practical design and implementation, as well as theoretical type work.
Well, we love that at Altium because we really see, as we're out among students in university, a big need for that hands-on, particularly because there's really a shortage of talent in our industry, whether it's design or technicians in a board shop or assembly shop. Can you tell us a little bit, and I know that's something you know about and something that's near and dear to your heart, could you tell me a little bit about what you're hearing in regards to the shortage of talent in the industry and what specifically you're doing to address that?
So you hear about these ebb and flows within sectors within the educational area. We used to have, a high-level kind of expertise within circuit design and layout and stuff like that, and that kind of faded away a little bit, but now you see this resurgence in manufacturing across all sectors that are trying to tap into this kind of talent field of engineers. And as a university, we want to rise to that challenge and basically equip our students with the necessary skill sets that they're going to need to drive the next generation of technology out there.
Well, I can't tell you what it means to me as a person who has been probably 25 or so years in the printed circuit board fabrication assembly to actually present to a class called printed circuit fabrication, a class at a university. So that's really great. And
And as you see, we're in the lab here. This is where one of the labs that the students are using, where they're actually making printed circuit boards.
So tell us a little bit about this room and where this equipment came from, or what specifically they're doing in this room.
So we have a number of rooms, and that's one of our, building a program, you've got to find lab space if you want to do hands-on type of things. And so we've had to kind of stitch things together to a certain extent. So we have different laboratories that we're using across campus. This is my prototyping research laboratory, but we have fume hoods that are able to handle the chemical processing, the wet chemical processing that the students need to use. So they do some of the board etching and development stages within this room here. And anything that's sensitive to photoresist, the white light and things like that. We have other labs that are in different locations. Trying to bring all that together would be a really nice piece of that, but we're making it work with what we can. And the students are in here and working in small groups, and they rotate around the lab. So we've been able to handle it.
So have you also, you mentioned Calumet, which is very close here to the university,
yes.
And have you been able to tap into, say, taking the students inside of a professional shop and exposing that?
Yeah, Calumet's been fantastic. We might have been able to run the course, but there's no way we'd have been able to do it in the time frame that we were doing without their expertise and help. They've not only provided their engineers and scientists and technicians to help us get things up and running where we have problems, they've also supplied a lot of raw materials for us and things that we've needed for the class. But as you mentioned, the lab tour, so what we purposely designed the lab tour to come at the end of the class in terms of the facility tour up at Calumet. So the students were already versed in the fabrication processes and already understood that. So they weren't going up to a new plant and then seeing all these processes they were not familiar with. They were already familiar with wet chemical processing, etching, developing photoresist and solder masks and things like that. So then bringing that in at the end of the class for the tour was really great. They got to see it on a much larger production scale and a much more automated and how better their boards look than the students. But
so how did they respond to being in that professional environment with drills and full-size plating facilities?
Yeah, they loved it. I mean, all the responses I've heard from the tours are great. Nobody. When we were talking about scheduling the tour and trying to figure that out, everybody wants to be part of it because they love that. They wanted to see, they've been doing it now, and they were really eager to see that kind of knowledge on what it's really like in a real board shop. So,
overall, having this hands-on experience, getting to see a shop like Calumet, and these are all EE students largely?
Yeah, we have a couple computer engineering, but the department is electrical and computer engineering, so you see students across those two spectrums. The course is meant as a introductory kind of course. Not that we have seniors that you've met before, and juniors primarily in the class as the first offering. You don't get to necessarily pick and choose who takes the class. We opened it up, and I was hoping to get to advertise this to the chemical engineers and material scientists, but it filled up with EEs right from the get-go. I didn't have to do any marketing or advertising with the class at all. It just all filled up. So we get even the CP, the computer engineering students realize the value here because we're talking about all these kind of areas blending together in different designs or firmware or products and stuff like that. So.
Do you see that, as EEs, that really the light bulb's going on for them as they, really get their hands on some of these chemicals? And
I think so. The part of the class, like I mentioned, was an introductory class to get them excited about electronic design, manufacturing, that area. But they can come into this without having circuits, without having electronics, without having a lot of that. So they can kind of get a taste of this, and I'm seeing that even in the students, they're really craving more, especially on the design or the population of the boards or all the other aspects of that. And so they've really gotten their hands on it, and it's interesting because of the feedback that I get. I actually am running one of the lab sections with my TAs, and so you hear comments back from the students of, this is great, I'm actually doing something with my hands, I'm actually working with this, and it's quite different from the normal type lab sections where you give them a lab, set them down on a lab bench and just let them work it out by themselves. You know,
Right.
you're leading them through there. You've got to have the procedures in place and the supervision, everything with the chemical sets, and but it's an introduction. You know, they understand what safety data sheets are now and things of that nature. So it's been good exposure, and you know, they realize that maybe that's not going to be their career forever, but they should have a taste of that and understand what goes on behind the scenes or in a board shop. So if they're working in those overlapping areas, they have a better technical skill there.
Why do you think there's sort of this disconnect on hands-on experience sort of pervasively in universities, and how do we get this message out that it's really valuable?
What is you know, some of it, there's a lot of reasons, I guess, and one of them is cost, right? I mean, these things take cost to do. We've got materials and chemical sets and things of that nature. We've been very fortunate in the support we've received from the community in terms of donation of materials or chemicals and things like that. So we haven't, while we've had to spend some money on the lab stuff, we haven't had to, you know, bear the full burden of that. So that's been really nice. So there's the cost aspect, but then from the student culture changing, you're not seeing a lot of students that are, you know, tinkering with things that you might have seen way back in the day, but it's changing, right? So you go and grab different components and you put those together and you integrate them into a system and program them or whatever you're doing. And so you're seeing that kind of different mindset coming into the university. But we can address that by offering courses like this where the students get in, they get their hands dirty, they're actually making things. And we had a midterm report presentations that all the students had to do, and they'll be doing a final one here next week. But it was really neat to see the pride and joy that they had in putting these presentations together, what went right, what went wrong with their processing, and it was really nice to see that. And they were very happy about it. They were smiling, they were making jokes. So I can say pretty certain that they've enjoyed the class overall. So it's been good. And trying to address those, challenges is part of the university's role and what we should be doing for our students.
Yeah, it's really truly music to my ears, and this is why I wanted to have you on the podcast today. I hope we can inspire other universities to follow your lead here. So obviously having Calumet clear by and be such a wonderful support for you has been very valuable. If you could wave a magic wand, what else can we do as industry to support your program? And, what are things are on your wish list? What more would you like?
So some of the things, university, obviously, they want better talent. They want better students coming in to start on that process to hit the road running right away. And so one of the things that we can work on, and we're trying to do, right, when we start talking to companies about lab sponsorship. I mentioned the fact that we have several labs that are separated. One concise facility would be really nice where we could bring everything together, make that a showpiece. In this lab, as you look around, you don't see any windows to the outside world. So we're missing a large population of potential students or visitors or anybody coming through there that's seeing that this work is going on. So there's a lot of different areas that students can go into, and you don't need to force them into one area or the other, but you should definitely expose them to some of that. And so having a larger space that supported this kind of infrastructure that made things more centralized and localized and gave visibility to tours, and the parents that are coming through, thinking about kids that are coming to school here and that sort of thing. And the companies can get the brand recognition. They can, and beyond that, then the next level there is more interaction. So companies sponsoring projects and being mentors to these students, and because the students really respond to that very well. Whenever they see somebody with a real product that's working at a real company, they love that interaction. The faculty members can teach them the theoretical stuff and things like that, but when they really get down into the real life things that's going on, they want to talk to the engineers that they're making their livelihood out of that thing.
Right.
And so being a faculty member and an advisor for some of these teams and seeing that interaction, that's really when the students really perk up, is when you have a really good mentor that's helping, guiding along the way. So we look for opportunities to broaden that sort of thing out within the electronics design manufacturing kind of field.
So the talk that I did today was to sort of help students think about the skill sets they need to onboard as potential future design engineers. So that's part of what you call a guest lecture series. Can you touch on that a little bit and tell us about your series?
And this has been one thing that's quite different from most classes. The course itself is heavily into the lab, right? The students are building projects, but there's also the lecture component of that. And me, rather than me trying to cover the various aspects of everything, it was, you know, a much better application to go out and look at industry resources and try to bring that talent in. And as I mentioned before, the mentorship and the interaction with industry is what really piques students' interest. So why not bring some of those talent into the classroom and have them give their briefings on various topic sectors, and the students are, you know, exposed to a wide area of different technologies, engineering disciplines, and team environments and things like that, and really trying to broaden their experience. You know, they've got the core piece of their educational knowledge, but how do they cross that across the whole spectrum, you know, of different type talents? And that's been really great. The lecture series filled up. You know, we didn't have really any days once we got going that was open for class. So, but the students, like I mentioned, the midterm reports, we actually did that on a day they normally wouldn't have class, which is kind of uncommon for students to want to do that. But they wanted to do that and they were willing to do that. But we had to do that outside of the lecture series because we had such great lecturers lined up, including yourself, to do this.
So can you give us just a smattering of the topics you've covered during this series?
So they've ranged anywhere from electroplating within the printed circuit boards to solder mask to assembly to you know, Happy Holden was in and gave some talks on future of this kind of industry and where that's going. We didn't pick in terms of straight linear kind of progression in fabrication, but just, you know, whatever worked with the lectures schedules and things like that. So they got to see all these pieces, you know. So if they saw some of the pressing issues, you know, how you do a multi-layer press within a couple weeks of when they did that in the lab, that was great. But even if they saw that later, they might have already had experience with that in the lab, so it resonated as well too. So we had just a smattering of all kinds of different topics, which, you know, from a student's perspective, can be a little daunting and maybe scary at first because they, you know, to a certain extent, they want that kind of structuredness. But with the generation now, they're a little bit more adaptable and like that kind of thing and can move with the flow a lot. They're used to turning things, you know, 90 degrees and going in a different direction.
That was an excellent interview that Judy did, and it also brings up the point that we really can't stress enough that we owe a great vote of thanks to the Altium and all of the other companies that have donated time and materials and travel expense and all sorts of things to help us bring this off. The important part here, of course, for those of us that are graying out of the industry, is that the young people that we're exposing to this are the future of our industry. And very early in the first year's session, we did a series of video interviews with some of the students who were available and captured some of their thoughts, some of their observations. And I will caution you that this was very early in the process, and we really need to do this again and again and keep up to date. There are some written comments that won't appear in this video that were pretty laudatory of Dr. Middlebrook and the effort as they got down towards the end. But I'll leave this to the students' comments, and I hope you're as encouraged as I am when you see the young people that are coming along behind us.
This is a course we put together, basically has multiple tiers to it in order to get students interested and expose them to the area of electronic design, manufacturing, and testing. This is just one course out of greater courses that'll be coming along that'll implement that, but it really tries to stress the fact of getting them into the lab, putting their hands on some of the equipment, and utilizing that, making simple circuits, simple printed circuit boards, but understanding some of the challenges and the design process. So even if they're not tied directly to that, if they're designing the circuits, they will have a understanding of how that's done. So if they're subbing that out to a vendor or something like that, they'll have a better sense for what they're asking for and the requirements and the standards that are incorporated into that. Okay?
Thank you, Dr. Middlebrook. All right, guys. I'll run through a question. I'll ask you to, those of you that have a comment or a question or a response, I'll ask you to say your name and then speak up good and loud so we capture it, and we'll go from there. The first one is the obvious one. What prompted you to decide to sign up for this class in the first place?
I guess my name is Michael. I've had some experience doing microfabrication for wafer level devices like PN junctions and that sort of thing. I kind of wanted to expand my understanding of how everything's manufactured and go from the chip level to the circuit board level, kind of see how those are related.
Have to see something that you're going to put your chips on.
Exactly.
Who else?
My name is Max, and I took a course that was called Introduction to MEMS, and that was microelectrical and mechanical systems, and I thought that might be an interesting, this could be another interesting course that has something to do with that, learning about how to take, even small systems and be able to produce them or fabricate them, or in this case, circuit boards. So I thought this would be an interesting course to take after taking that course.
Yeah, it's the boundary that used to be. We used to think it was pretty clear cut between the wafer level fan out and the MEMS fabrication and the printed circuit fabrication. We used to think it was pretty clear cut, but the boundary is getting very gray down at the small feature size. So a lot of this stuff is going to transfer back and forth, and we're also stealing concepts from the microelectronics fabrication guys that are becoming necessary as the circuit board features get smaller. Who else? Who else has got a comment there about how you got into this?
All right, my name is Steven, and I've worked with a bunch of different embedded system designs and created different PCB or circuit boards, and so knowing the inner workings behind how the circuit boards are actually created, I thought would be helpful to help design better parts.
It certainly hope so. Anybody else, or should we move on?
So my name is Evan. I'm kind of nearing the end of my college career, but I'm going to be working as an analog engineer coming up in the near future. And so pretty much seeing as PCBs are ubiquitous in industry, it's going to be, I think, a useful course to have that background going into a professional career.
Thanks, Evan. All right, we'll move on to the next one then. We've kind of touched on this already, so this one may be a little redundant, but what do you hope to get out of this class? What do you hope to take away, both from a knowledge and maybe from a career standpoint?
My name's Tyler. One thing I hope to take away is we really don't get a lot of experience with PCBs in our courses as EEs, and I'm really hoping to get a better understanding of that. I'm going into hardware design, so having a little bit more hands-on experience with how these things are made from the ground up really does help.
For me, I think it's so far been a really interesting course. I like the labs a lot, and I think I'm excited to keep going. And I think for me, it's too early to say, just since we're only 2 labs in so far. So I think in the future, I'll have a different opinion, hopefully a positive one. So,
is there something about the class that's been particularly good? I mean, as compared to the other classes that you attend there at Michigan Tech, is there something that stands out that's a little different, a little out of the norm here?
Oh, my name's Lucas. In terms of, I guess, my opinion on what stands out a lot for this course is the focus on lab. I prefer hands-on learning. I prefer to be active in the process. When it comes to any course, even here at Michigan Tech, the part I remember most is lab. With this course's heavy focus on lab, it's been a very memorable component, so it's been very easy to pick up and retain concepts versus other courses where it's just lecture.
One thing kind of tying into the labs there, I enjoy that, like the labs that we've been working with so far have been very kind of like small scale, like small groups. So it's just like you, your lab partner, and a TA working on something in like either like the dark room or the multi-press. I think that like really small scale, small group work, it's been very beneficial as opposed to the normal labs where you have like 20, 30 students in a lab with one TA.
Yeah. And has there, let's move on then. What's the, one of the things that we're concerned about, want to do for improving this for the future is there something that's been particularly hard or confusing or hasn't made sense that we could work on?
So I'm Evan. At this point, I think most of the challenges that we've seen so far are just getting getting a rhythm to working in the lab and getting some of the kinks out. So far, I think all the machinery's been working pretty well and it's been functional. I think we're still kind of learning what its limits are and where those improvements need to come, and just getting more familiar with the process and the equipment.
Yeah, I think you guys all owe Dr. Middlebrook a vote of thanks because he spent an awful lot of hours. I've spent a little. Some of you have too. I know, Evan, you spent some time in there getting this equipment up and running the first time. But yeah, we're all pretty excited out in the industry too about the fact that you guys have the wherewithal to actually do this, the whole process, start to finish, in your own hands there. I mean, you can go over to Calumet and see it in the large scale, but you'll get a really good picture of the actual process out of what you're doing there. Anything else, or is it still too soon to say? I mean, there's going to be things that are going to go wrong. I don't know what they are yet, but there's going to be things that are going to go wrong. That's just the way it is. But go ahead.
Yeah, Lucas again. I guess one of my other concerns that we haven't, due to just how the semester's gone flow-wise with cancellations and things like that, it's been kind of a rough semester. But that aside, one of my concerns going forward is industry to academic translation. Right now, we're at an academic level, and we talk to a lot of industry people, like Tyler said. One of the problems I can see with that is, while we want to make that jump, industry terminology doesn't always align with academic. So we want to understand, but we're missing a connection there. So that's one of my concerns, but I haven't gotten, it doesn't seem like it's been too much of a problem right now.
No, and Lucas, if it's any consolation to you, it doesn't translate between segments of the industry or between companies in the industry either. So, you know, welcome to life, Lucas. It's the way it's going to be. Sorry. One thing we are doing too, those of us out in the industry are out chasing around, and we're trying to make if possible, internships for those of you that aren't graduating this year. We're going to try and see if we can't get you out and see some of this work in the real world, and maybe even participate a little bit. But I think this will give you a good grounding. I hope so, anyway. Shall we move on? Okay. Has Dr. Middlebrook shared any of the read-ahead materials? We've been proposing to use the printed circuit handbook. It used to be edited by Clyde Coombs, and now it's being edited by Happy Holden, who's going to be giving several of your lectures later on as well. Have you looked at any of that material, that background material yet?
Tyler again. There has been a little bit of it, but like Lucas brought up with the cancellations 2 weeks ago, Winter Carnival last week, and Middlebrook being down at a conference, it's kind of been a real rocky start.
Yeah.
Our first couple weeks were based off like safety and stuff like that, so we really haven't jumped into anything yet. So.
Okay. I would encourage you, and we're going to try and do a better job too of giving you, before each lecture, we'll try and give you some specific chapters. I know I've given Dr. Middlebrook access to some older files of the printed circuit handbook, so we can do printouts or put them in that, I forget what they call it, a shared drive that you guys use, but so that you can do the read ahead. And I'd encourage you to do that, because if nothing else, the jargon will at least be familiar to you when we go through those sections. Because those of us in the industry do tend to, we kind of forget that, since we've been at it so long, we kind of forget that some of what we say is Greek. All right. Let's move on then. Again, it's still early days, but can you see any evidence or see any preliminary indications of things that we should maybe hit a little harder, cover a little more depth or detail? Again, it may not be, this may be premature, this question. Anybody? Okay, that's a pass. I guess just to wrap up then, I don't want to keep you guys too long. I know you guys got other things to do. This time I will go around the room one by one and ask for your initial impressions. What's been particularly good, if anything that we need to revise, and what do you think for those of you that aren't graduating this year or coming back as grad assistants or something, as TAs? What should we be looking at for next year? Evan, we'll start with you. You're on just dumb luck. That's where you are.
So I think for me, a lot of it does seem a little bit early. I'm very, from the information that I have got, it's been a very good initial exposure to it. I think it's still too, or at least for me, it's too early to say what things will need to improve for the future. I think the more this runs, there'll be kind of maybe a more methodical approach to what, like, the order things are introduced in. Right now, just by kind of nature of the beast, we're jumping around a little bit. I think all the pieces of the puzzle will fit together by the end, but developing a more set curriculum, I think, as it evolves, will be good.
Yeah, it's a good point, Evan. I mean, this is the first time that we've tried to put this thing together, and as you have commented and others have commented, we kind of put it together on the fly. So, yes, we anticipate that we'll be learning, what we need to do differently, and of course, some of it's going to be lab limited in terms of sequence, because you can't all be working the press on the same day, for example.
Yeah.
So, okay, next.
My name is Michael, and I guess so far I've liked that we've kind of done some trial runs of some of these processes before we've tried to fabricate our actual final board. So like last week, one of the things I was doing was the Stouffer step, going through that process before we actually are trying to pattern our board. We get to learn how do we expose it, how do we laminate everything, how does the developer work. So if we mess up there, we're not going to mess up our final board and not have an end product. I guess the one thing I think that could be improved is locations of the labs.
Yeah.
I know it's something Middlebrook's been working on, but there's all sorts of different requirements. The lamination has to be done in a room without UV light. We need chemical hoods for certain processes like the development and the etching. So if eventually we get them all in one location, I think that would be a big improvement.
Yeah, next time I'm up for one of my guest lectures, I'm going to have you guys show me where these things are again, because I forget how to get from one to the other. Next.
All right, I'm Steven. I think the PCB fabrication is sort of, there's a bunch of errors that can happen, but there's no guideline of which ones are more common to occur and which ones are extremely critical about, say, if this error occurs, no matter what, it's gonna not function at all. Or versus, like, if there's like a little bubble, it won't destroy your entire board. So we seem to get all of the errors and all of the mistakes that can occur, but just not the ones that are like not defining which one's critical and which one's not critical, and which one occurs and which one's very rare to occur.
That's a good point, Stephen. We've got a process troubleshooting section that we'd like to fill for later, and we'll try to pull that in. I think that's a real good input, Stephen. We'll try and do that. The other thing that maybe you haven't stumbled over yet is that the cumulative effect of multiple small errors can also bite you, and unfortunately, usually by the time you've got your board completed, so you've got all your time and all your money, and in this case, all your time, which is also true in production. That's where it gets you, is when you find out that you're 30 seconds from the design delivery date and you've got to start over. Next, please.
My name is Jacob. So far, enjoyed the class a lot, at least with like the lab portion and all the lectures we've had coming in. The only real concern is kind of just nature how it's been with this being a new course has been haphazardness of some stuff, whereas like, not having an SOP, available for some of the, labs initially going in, or, some stuff not being able to like upload it on like, information, initially. But again, it's more kind of a situation of like, it's a new course, getting everything ready. I know Middlebrook has a lot to do, getting everything done for it. So I think it's more
Right.
something that we worked out through future courses and getting further into the semester.
Yeah, we had this discussion earlier on, and I do have to admire the fact that he at some point you have to shoot the engineers and go into production, and he said, let's get it out there, let's find the kinks, let's fix it, rather than wait for it to be perfect. Otherwise, you'd never do anything. Next, please.
I'm Tyler. One of the things I think is doing really well in this course is the small class size, the small lab size. Just the culture of the class itself, it's a lot more open. I mean, you can see us here, we're actually just doing an interview and all that. We've never done this with any of our course, really. One thing I got to do was, the first lab I did was photo plotting and mass development. We ended up, because a lot of it's just waiting for the photo plotter to do its work and all that, we ended up basically being able to sit there for an hour and just have a conversation with Dr. Middlebrook himself, which is basically you're not able to do that in any other course. We've done that with our TAs as well. We can just talk about like, oh, hey, what if this happened? Or what would happen if you did this? What's industry looking for? So I think one of the best things this course is doing is the small class size allows you to actually get a lot more than just the course material. Getting a lot more bang for your buck.
Good input, Tyler. Thanks. Next.
All right, I'm Lucas. So in terms of this course, I guess I agree a lot with Tyler's statement, where it's just the closeness of the class. I'm a transfer student, so I'm used to the community college where it's smaller class sizes, more personal with your teachers, and that's something that I really like I've gotten to experience with this course, is just that closeness among students, the closeness to the teacher. It's been good to get, I guess, better interactions, better information, and just it feels easier to retain the course. Smaller setting.
Very good. Thanks, Lucas. And finally, but not least.
And I am Max, and I wanted to say something that Lucas brought up a while back earlier. Actually, Tyler did, I think. He said that the guest lectures, it was nice to have them. I think that's a really cool dynamic that this class has brought so far, just because I haven't seen many classes at Michigan Tech who have offered guest lectures, and so many of them, and such good ones, to come into class and talk, and even, with Skype, to talk to all of us about some of the industry. And I think this is really cool to be so close, tightly knit with industry, whereas a lot of these classes are so far apart that I feel like it's two other worlds. This is kind of merging those two, I think.
Well, that was what we were going for. Let's see how well we do.
Since the beginning of this project, it's always been our intention to try and replicate this basic model of industry, academia, collaborative classwork at other locations around the country, so that we can provide that access to new replacement staff, new professionals, in accordance with local needs. We've stressed very much from the beginning that at any of these clones, and I use the word advisedly, that it need not necessarily be an exact duplicate of what was done at Michigan Tech. The Michigan Tech Calumet project was obviously designed to address a local need. Calumet needed new young entry-level engineers with some familiarity with the basic technologies. Elsewhere in the country, we've talked to a number of people, and the need is more acute in terms of technical staff at the production floor level, 2- and 4-year degree programs, or even just basic training programs. So if that's the case, then that's what has to happen, because it has to be self-sustaining at the local level, and it has to answer local needs. So it's been very encouraging recently to get some additional support from the Department of Defense's Industrial Base Analysis and Sustainment Group through their Cornerstone Other Transactional Authority that will permit us to accelerate and broaden this outreach. There are a great many people that have supported this effort and are currently involved in this effort, and I can't reach out and credit all of them in this short time, but a slide that follows this will show you at least a smattering of the people and kind of an idea of the cross-section of the industry and academia that are involved in this effort, and I'm very grateful to those people. Thanks for listening. As you can tell, we're all pretty excited about this, and pretty hopeful that we'll be able to bring this to a much broader audience. I'd like to thank SMTA for this opportunity to give you this introduction, and would like to invite you to reach out and contact either myself or Tamara Shepard of SMTA if you'd like to get involved, either as a subject matter provider, or if you have good contacts at a specific locale that you think might be a good node for this sort of industry, academia development. We'd very much like to hear from you and see what we can do to help. Thanks again, and I hope you have a great rest of the SMTAI.